Good day. So this is your teacher in Mathematics 10. I am Mrs. Jocelyn B. Amoyo. Our first lesson involves the quartiles of ungrouped data. Before giving you the highlight of today's lesson, so let me show you the three objectives today. Illustrate the measure of position on quartiles. Second, describe the data using the quartiles. And number 3, reflect the use of measure of position on quartiles to real life. For today's keywords, position, it refers to where the object is located. For example, in the list of names of 4 students, MJ comes first, Patrick second, Anthony third, and Christian is the fourth. Middle value, it deals with the center of a given group. As you can see in the picture, a girl or a teacher who is singing national anthem is at the middle, so that is what you call the middle value. Quarter, it concerns to the division of a whole into 4 equal parts like this. And also the same with the 12 months of a year, where a year can be divided into 4 equal subgroups or quarters, wherein the first quarter begins in January and ends in March. And also the same with the second quarter, it starts in April and ends in June. That is also the same with the succeeding quarters. And they are called the data set. A data set can also be consisted of letters, numbers, symbols, and more. Ungrouped data. It is composed of a raw data. A data value, a value in a given data set. As an introduction to our lesson, look at the pictures before you. Have you recognized them? Did you get your score taking the National Career Assessment Examination or NCAE when you were in grade 9? Do you know your rank in your class? How about the score you need for each subject to qualify for honors? Did you ask by your parent to fall in line according to height for some reasons at home? Or have you thought about the scholarship given to those students who belong to 5%, 10%, or even 25% of their graduating class when entering college to some state universities? Well, those are the events and concepts that are the main concern of today's topic about the measures of position. They are quartiles, deciles, and percentiles. But in today's lesson, I'm gonna show you how to solve quartiles of ungrouped data. Quartiles are values that divide the data into quarters. However, these quartiles are not shaped like pizza slices. Instead, they divide the data into 4 equal segments, for which values or numbers lie on a number line. As you can see in my first example, I used 5 numbers which are arranged from lowest to highest or in ascending order, for which 0 is our second quartile, which is denoted by the symbol Q sub 2 and known as the median. For the first quartile that lies between -2 and -1, which is called as the lower quartile. For the third quartile, which is represented by Q sub 3 and also known as upper quartile, bounds between numbers 1 and 2. In addition, 50% of the data below the median bounds in this place, and another 50% of the data above the median lie in this place. For the second example, you are asked to illustrate the median, the lower quartile, and the upper quartile of the scores of 11 students who took a 5-item test. Here are the scores: 2, 1, 3, 3, 3, 5, 2, 4, 4, 2, and 5. As you can see, the scores of 11 students were not arranged in increasing order, so we need to follow the steps. First, Arrange the score distribution in ascending or increasing order. We have 1, 2, 2, 2, 3, 3, 3, 4, 4, 5, and 5. Second, look for the measures of position, the median, the lower quartile, and the upper quartile. First, we have to look for the middle value, or the second quartile. Since the second quartile, or the median, divides the dataset into two equal segments, then it creates the lower half and the upper half. And it seems that the lower half contains 5 data values. We can easily find the first quartile. That lies on the third position, which is also the same with the third quartile. That is the middle value of the upper half. That is found on the 9th position. For the third example, we have a data consisting of the ages of 10 students who participated in an online math class. You need to solve for the lower quartile and the upper quartile using the Mendel-Solf formula. We have 15, 16, 16, 17, 14, 16, 15, 15, 17, and 18. As you can see, they are not arranged in increasing order, so you need to follow the steps. Arrange the age distribution in increasing order. 14, 15, 15, 15, 16, 16, 16, 17, 17, and 18. Number 2. Apply the Mendel-Solf formula, that is Q sub k is equal to k times the quantity of n plus 1 all over 4, where k represents the position of a data value in a given data set, and n stands for the number of data. And lastly, solve for the Q sub 1 and Q sub 3. Mendel-Solf formula is used to locate the position of a data value in ungrouped data using the quartile. And the computed value for this is written in an ordinal number. To show you, let us have first the first quartile. For the first quartile, k is equal to 1 and n is equal to 10. So let us substitute all the values in the equation. We have Q sub 1 is equal to 1 times the quantity of 10 plus 1 all over 4. That is equal to 1 times the quantity of 11 all over 4. And it gives a quotient of 2.75 or approximately 3 or third. So the lower quartile lies at the third position, that is 15. Remember that there is a rule for even numbered data, especially for the first quartile and the upper quartile. For computing the first quartile, you need to round up the computed value. When we say round up, the decimal number is transformed into a whole number without following the rule of rounding off. In this case, it so happened that the computed value for Q sub 1 agrees to the rule of round off and round up. Okay, let us look for the third quartile. So remember, once again, the rule of even numbered data in terms of third quartile. So you need to round down the computed data. Okay, so once again, using the Mendel-Solf formula. So in this case, our k here is 3 and n is 2. So let us apply all the values in the equation. So we have Q sub 3 is equal to 3 times the quantity of 10 plus 1 all over 4. That is equal to 3 times 11 all over 4. And also equal to 33 all over 4. That gives us a quotient of 8.25 or approximately equal to 8. So the upper quartile lies at the 8th position, that is 17. Let me have an add-on looking for the second quartile or the median of this even numbered data. Let me use the Mendel-Solf formula to look for the second quartile, where k is equal to 2 and n is equal to 10. So let me supply all the values in the equation. So we have Q sub 2 is equal to 2 times the quantity of 10 plus 1 all over 4. That is equal to 2 times 11 all over 4. That gives us a quotient of 5.5 or 5.5. This means that the median lies between 5th and 6th positions, that is 16. It so happened that the two middle values are the same. How about if not? What are you going to do? Yes, you are absolutely correct. All you have to do is to add the two middle values. And then, divide the sum by 2. Just like using the formula, wherein A and B represent the two middle values. By using the formula in this data, so we have 16 plus 16 all over 2. That gives us 32 all over 2. And then, that is the reason why we have 16 as the middle value. For the last example, we have this kind of problem. The lower quartile of a dataset is 8 data value. How many data values are there in the dataset? Do you know what is asked in the problem? Yes, you are genius because we are looking for the value of n. For the solutions, you have learned that the second quartile or the median divides the data into two equal segments. We have the lower half and the upper half. It seems that the 8 data value lies on the first quartile. Then it is the median of the lower half of the data distribution. It also observed that there are 7 data values before and after the lower quartile. So the number of the data values before and after is given by 7 plus 7 plus 1, where 1 represents the data value placed in the 8th position. That gives us a sum of 15. That is also the same with the upper half. That makes 15 data values plus 1 for the middle value. The mathematical sentence is 15 plus 15 plus 1 is equal to 31. Therefore, the number of data values in a set is 31. If you want to check if your answer is correct, you may use Mendel-Sol formula. You need to write down the given and then apply that to the formula. By manipulation, so we obtain that the value of n is 31. In this example, you will learn how to describe the ungrouped data. And for you to be able to describe this, you need to write down all your observations. Here are the possible observations or descriptions of the ungrouped data. The least score is 1 and the highest score is 5. The median score is 3. The 50% of the students got the scores of at most or less than or equal to 3. The 50% of the students who took a 5-item test got the scores of at least or greater than or equal to 3. There are 5 students who got the scores of less than or equal to 3 in the lower half. There are 5 students who got the scores of greater than or equal to 3 in the upper half. The 5th student in a class surpassed 4 students who got the scores lower than him or her. Did you get the same observations? Well, if you got them all, congratulations. So let us proceed to the next example. For example number 2, I will use the third quartile, which is 4, in describing this ungrouped data. And here are the possible observations or descriptions of the ungrouped data. The 75% of the students got the scores of at most 4. The 25% of the students who took a 5-item test got the scores of greater than or equal to 4. There are 8 students who got the scores of less than or equal to 4 below the third quartile. And there are 2 students who got the scores of greater than or equal to 4 above the third quartile. And for the third example, the first quartile is the basis in describing this ungrouped data. And here are the possible observations or descriptions of the ungrouped data. The 25% of the students got the scores of at most 2. the 75% of the students who took a 5-item test got the scores of greater than or equal to 2. There are 2 students who got the scores of less than or equal to 2 below the first quartile. And there are 8 students who got the scores of greater than or equal to 2 above the first quartile. I hope that you understand and apply all the concepts that you have learned about quartiles of ungrouped data. And I have this feeling that you are all excited and prepared answering the 4 learning tasks this day. Good luck! For learning task number 1, find the first quartile, second quartile, and the third quartile. Use the scores of the 12 students in a 10-item test. Here are the scores: 3, 7, 5, 5, 2, 6, 1, 8, 8, 7, 7, 30. Learning task number 2. Describe the score distributions of 12 students based on the quartiles. Learning task number 3. Aqua running has been promoted as a method for cardiovascular conditioning for the injured athlete as well as for the others who desire a low-impact aerobic workout. A study reported in the Journal of Sports Medicine investigated the relationship between exercise cadence and a heart rate by measuring the heart rates of 20 healthy volunteers at a cadence of 48 cycles per minute, where a cycle is consisted of 2 steps. The data are listed here: 87, 109, 79, 80, 96, 95, 90, 92, 96, 98, 101, 91, 78, 112, 94, 98, 94, 107, 81, and 96. You were asked to find the lower and upper quartiles of the data. Then describe the data using the quartiles. Learning task number 4. The lower quartile of the height distribution of grade 10 students is located at 11th place. How many students there will be in the class? Show your solutions and check your final answer using Mendenhall formula. The lesson today about quartiles of ungrouped data is guided using these references. Thank you for listening and watching in this video. But don't forget to send in all your answers through my DepEd account, FB account, and if you won't be able to reach me using your data or internet connection, you may contact me in this number. I also accept free consultations 24/7. Goodbye! See you on my next lesson!